Welcome everyone. We're live here with Tenderly today for another workshop. Hey man, how are you?
Hey,
Um,
pretty good.
awesome, awesome. Busy days around in Web3. Everyone running around, lots of things happening, and I'm happy that's how we're rolling here. Today we're gonna see a little bit about Tenderly, an amazing tool that's been around for quite a few years already. They have a big suite of uh, products, services, and lots of things that developers, builders can use. Today we're gonna go over a big kind of an intro and an overview of all the things that they have. We won't be able to fit into 1 hour a deep dive into all of them. So today we're gonna make an overview, just check a few of their
Mm.
products, so you get an idea and a sense of the things that you can do with Tenderly and their new things that they've been building in the last months and years. So Nenand, how are you, man? Can you present yourself to the public and what are we gonna learn today?
Yeah, well, thank you very much. My name is Nenad. I'm DevRel lead at Tenderly, and yeah, I come from an engineering background, but I sort of ended up in DevRel, which is sort of something that I like doing in one place. And yeah, I'm in Tenderly for, let's say, 2 years or something more than that. And today, I think my goal would be to answer the question, what are all the cool things that devs can do using Tenderly, and how their lives and work can become easier. So, as you said, there's a lot internally, and we will not fit all of that in an hour. But I will try to just give you like a big picture overview, and then dive a little deeper into some aspects.
Awesome. A lot of mode builders were really happy that mode and Tenderly are now like integrated because a lot of the services are used by tons of teams and usually you cannot find a lot of these tools that even what makes me happy is that they integrate with each other, right? Like, so you have Web3 actions, you have alerts that then you can mix together and get a very nice user experience from the builder standpoint. So
Mhm.
yeah, happy to see this overview, happy to host it here and excited to see what you have for us.
Awesome, awesome. So I say let's dig in, and I
Yeah.
want to start with the big picture. So when it comes to the big picture now, do you see the screen still? I guess
Yes, we
you do.
have the
Yeah,
screen live now. Perfect.
awesome. So as you said, we have a lot of features that sort of fit in together, and we compose the features in a way. So I'll divide them into three categories. One would be all the stuff that's useful for development and staging, and we started out actually with the debugger. That was the first thing how Tenderly came to being, because we had very detailed transaction traces, and these are available through the UI and the API. And the latest addition to the offering there are virtual testnets, which allow you to create your own working copy of mainnet data hosted elsewhere apart from your computer, so other people in your team or community can access that. And we'll dive into examples around this throughout the session today. The second big bit is security and monitoring. So another thing people know us for are simulations. So with the simulator, which has a UI interface, but also simulation RPC and simulation API, people can see what's going to happen to their transactions if they were sent to the network. So this is like proactive security measures. So you see all the token transfers, so you know it's safe to sign a transaction. But also you can use it to test various scenarios, like if you're trying to figure out if there's a vulnerability, you can just simulate interaction with contracts and figure out whether or not there's a vulnerability in there. The second bit to the security segment are alerts. I like to call them reactive security layer that Tenderly brings, which means that practically you will get an alert on your Slack or Telegram or PagerDuty if something happens on chain based on the criteria you defined. And the example that you mentioned, you can mix Web3 alerts with Web3 actions. So let's answer what Web3 actions are. These are, let's say, serverless backends for smart contracts. You can define rules when you want your little bit of JavaScript to run. So let's say an event is emitted from a contract, and your little function gets ran. And of course, you can compose them. Alerts can trigger Web3 actions. So criterias of what is important, and then a little runtime so you can avoid adding additional backends or whatnot. And the last bit would be the extensible RPC node. So we also have a node RPC within the offering. It comes with extensions. So first of all, there are methods that do very precise gas estimation. Actually, it's gas profiling, but we'll talk about it in the demo. It's extended also with methods that give you transaction traces. It also has the simulation RPC in there, so you don't need to integrate yet another REST API. You can just use the simulate RPC method. And last but not least, you can also define your own methods on the node. So you can just pack a little bit of functionality and expose it as an RPC method.
I do have a little question there. Not going to dive deep yet into it, but I thought it was super interesting, like the concept of adding functionalities to nodes and like extend, like code your own and prepare your own. Why would you do that? Like I see the value, but why? When would you say, okay, this is the way to do it for builders?
Yeah. So I mean, for me, one reason would be if I have, let's say, a calculation, something that consumes external APIs and maybe get something from the RPC, and I don't from a chain actually, and I don't want to really create a REST API that others can integrate to, or I'm just too lazy to build the thing fully during the prototyping phase. Well, that makes it super easy to create like fast REST API or actually RPC API. So you can encapsulate some logic there in a fast way, and maybe move it to a different solution later on. But essentially, yeah, to just get some functionality in there, get it fast, and make it easier for others to consume it.
For a quick test run on a cool concept that you're trying to do, maybe it's a really good thing to use. Totally.
Yeah.
Love it.
All right. So that was a deep dive, and I know there's a lot in there, but I promise I'll try to slow it down as we go, and I'm going to zoom into some of these things. So today we'll see the testnets, we'll see the debugger, we'll see the simulations, and we'll see alerts. So those are the things that we're gonna actually see in action, and hopefully somebody gets inspired how they could use it in their own project. All right. Let me jump into my dashboard. So I created a Tenderly 101 project here, and I'm gonna start things off with virtual testnets. So that's let's say the latest thing that we released maybe 2 months ago. And what virtual testnets are, they allow you to create your own, let's say, a replica from an existing EVM network. So anything that is supported on Tenderly, you can actually create a virtual testnet out of it. So I just before showing anything in the UI there, I would like to give you an overview of. No, it's not there. Just 1 second. Yeah, I'm looking for this very cool illustration that we got in there that would help us understand things a little bit easier before we dive in. There we go. So this would be your mainnet chain, and you can create your own working copy out of it. So that means
can you make it bigger, a little bit bigger,
yeah, sure.
like whole screen? Thank you.
Yeah.
Oh, there we go. Great.
Yeah. So yeah, that didn't work as expected. Yeah, let me just zoom in this way.
Yeah.
All right.
There we go.
So the idea is you would have your mainnet. the original chain. And when creating a virtual testnet, you sort of fork it. So whenever you send a transaction to it, it creates a new block, and all the state from the point before the point of forking is fully available in there. The cool thing about it, it can be shared with anybody in your team, but what's even cooler is that it has a continuous state sync. So in this diagram below, when state sync is on, what happens is that your testnet will continuously see any update happening on the mainnet. So you can imagine that in this block, we had a modification, an Oracle update. So when I send transaction to this teal block on the bottom, I will actually see the latest value that's written to the Oracle. So you get everything that's happening on mainnet fully available on your working copy on your testing infrastructure. So that means all the protocols that you're interacting with, they will be, let's say, fully updated as you work on it and as you develop. So this is what virtual testnets are conceptually. And I'm going to go back into the dashboard here, and I'm just going to create one. So let's pick mode, and I'm going to name it mode 101. One important thing here is to actually set a custom chain ID, because if I just leave this chain ID, there is a risk of transaction replay attacks. So if we set a custom chain ID for this one, then that's not going to happen. And what I like to do is just to prepend test in decimal numbers to it. So whatever it is, I just prepend test, and I know it's a virtual testnet. So that's the secure part of it. Then we have a couple more options. One of them is to enable or disable a public explorer, because testnets, well, they come with an interface. You can think of it as a little Etherscan for your testnet. So I'm going to switch it on. And you can also control what's visible when it comes to contracts. So it can be that you're not exposing anything to people using this public explorer. You can expose ABI of the contracts you deployed, or you can expose ABI and the code of the contracts you deployed. I'm going to go for this option over here, ABI only, so we can see it in action. And the latest bit of this configuration is actually state sync. So here we can just say, we don't need state sync. I don't need freshest updates coming from mainnet. Or I could just say, fine, yeah, let's do the state sync from the parent network. So that's pretty easy. And when I hit create, that's it. This is all the time it took us to get an RPC that we can use and that we can integrate with in our projects. So
Wait.
here,
I'm gonna stop you right there, because what just happened is pretty powerful, and I do have a few questions. So,
go ahead.
number one, you just forked mode mainnet with all the state that it had up to now, and you have also the option to keep it up to date with mainnet, right?
Exactly. Yeah.
So, if, for example, I am a new DeFi protocol, and we've had this issue before where I would like, and I need to test a lot of things, but I don't want to make it public. I don't want people seeing the token, the new token that I'm releasing. I don't want people to see the tokens that we're integrating or all the things that we're doing. But we do need to work with a few teams as well. So as a protocol, I need to integrate others as well. So not only I can use this for me, for the rest of my team, but also you can share this with other team that's integrating with you to maybe run their tests and see if everything's working correct without letting the public know, right?
Exactly. So this is not on a public testnet. The contracts are not verified on Etherscan. So all that code is practically hidden, tucked away, and it's visible only to people you explicitly share it with. We'll touch upon verification as well. I know that's a big problem, still unsolved, and it is important. But for now, what we need to know is that the network is ready. There's an RPC, actually two of them. One of them is public, another one is admin. And you might imagine admin has additional tricks that we're going to see. So if I just copy this and send it over, well, you can just access the network and pretty much use it. And just to show you the public explorer, I just clicked there. So this is how it looks to the rest of the world. So if I just send this to anybody practically, well, you will see these transactions updating as they happen. Now, let's see a couple of things that you can do here. So first of all, let's add it to the wallet. So that's supported through a click of a button. So we added that, and it names the network properly. It's got the chain ID in there. So I'm going to hit approve, and that's pretty awesome. When I open my MetaMask, yes, I agree. You can see my address. There's no ETH on it, so that's pretty good. Now, another thing that we could do here, is it going to stay? No. Another thing that I can do here is actually fund my address in a pretty fast way. So this thing doesn't have a faucet that you have to wait for. It does have a faucet that's practically unlimited. So I just paste my address in here, and I'm going for 10,000 ETH. I clicked fund, and let me go back into my MetaMask. So I got 10,000 ETH for all sorts of testing in a matter of, I don't know, 20 seconds with talking included. So that's pretty neat when you want to, well, develop stuff or try things out, or try to come up with an attack vector that needs to move big amounts of money. But this is only the native currency. What's also cool is that you can add a ERC20 token in there. So you can also, you're also getting an ERC20 faucet as well. So any token that's compatible with the ERC20 standard, you can fund your accounts with that using this interface. Now, this is very nice that you can do it through the UI, but I'm assuming somebody might be wondering, okay, but is there another way to do it? Yes, there is. There is an RPC method called set balance and set ERC20 balance that allows you to easily fund accounts using just one simple JSON RPC request. So you would add the receiving address, and you would add, actually, these are addresses, so you can fund several wallets at once, and this is the amount that they would get. This is very handy, especially when you're, let's say, deploying your dApp for various sorts of testing, and you want your test accounts to be full when the dApp is deployed or when the contracts are deployed. All right, segue complete. We have a lot more stuff in there, and I'll come back to it as we go. But this is, I think, probably a question that builders would have.
Yeah. I would stop also here for a moment. You're a
Yeah.
DevRel as well, and you come from an engineering background, which I love. I'm kind of the same. I think we're gonna have a challenge from the DevRels or like Tenderly and all these dev tooling around to take away old bad habits from Web3 engineers that are used to doing all of this by themselves. So like deploying their own testnet tokens, having their own testnet, having like to do all of these things on their own, and the teams building all of this stuff and having this out of the box is super powerful. So if we got new people, new Web3 devs around watching this, just know that you're super lucky to have this already built. And for the old
Yeah.
folks, I would tell them just give it a try, because you would be saving so much time and effort to actually focus on what matters, to testing your product, actually working on your product, checking that everything's really working, and you shouldn't be worrying about all your setup, all the environment, and all that stuff. So yeah, just that, an appreciation moment. Yeah.
Yeah. Thanks for that. And just to chime in on that, so what I know as an engineer, inventing the wheel is of course hard, and it's a bad investment of time, but it's also very fun. And I understand the devs who who actually had to build a bunch of stuff on their own. That there's also an element of fun in there, but to move in a faster and an easier way, I think stuff like this is very, very handy and useful.
Yep. Genie P says here, fork on steroids. Totally. Yeah.
Yeah, you could say that, forks and steroids. Yeah. Awesome. So what I would like to do now is to jump into a little project to actually see this from a more of a builder's coder's perspective. So I'm sharing here a little scaffold ETH2 fork of mine. So you would see the standard hardhat and next folders in there, but I also added a Tenderly folder. So what this thing does is it allows you to create a new virtual testnet for staging purposes. So this is like the stage new. Then it allows you to connect your hardhat bit to that testnet and Next.js bit to that testnet. And this is all just configuration manipulation. And then we can see how, let's say, easy it is to have on-demand staging whenever you want it for whatever reason. And looking forward, you can actually wrap this in a GitHub action. So you could have your dApp fully staged whenever you have a commit practically. So let me give this a go. So the first thing that I want to do is run this stage new command. Now it receives an argument. So let's say this, and the argument will be the name of the environment, let's say, and I will need to add a chain ID. So this sort of broke, but what I need to do is tell this command, yeah, I want to create testnets for the following chains. So this is what I need to add. This is mode, and I'm gonna add Ethereum mainnet to it. And there we go. We have it created, and it's actually present in this environments folder, and there's a lot of that, but here's the one that we're interested for. So we have our chain ID that's prefixed with test. We have the RPC in there. So now from this configuration, I can take it and connect hardhat and next portions of the dApp. So I'm gonna jump into, no, I'm gonna stay here. And the next thing that I need to do is actually activate mode 101. So this sort of, oops. So this sort of makes this configuration to that testnet, let's say, actual. That's the configuration we're having. And the next bit I want to, well, of course, I want to deploy some contracts to this testnet. And again, I didn't do npm run. All right. So let's see what happened in hardhat. In hardhat, there's this configuration file that's called tenderly config. There's some linting errors, don't mind those. But we have an object that contains both the virtual mainnet and the virtual mode in there. When you go into hardhat config, you'll actually see that these networks are dynamically added, whatever's in this file showing up in there. So now I'm ready to deploy contracts to this. So before I do that, let me just quickly jump to the dashboard. And this is the one in there. And going back to, let me just, yeah, going back here. So you can see mode 101, that's the one I created manually. And these networks with funky looking names, those are the ones that the script has created. So I'm gonna go here. And as you can see, we have no transactions in there. We just have the 10 latest transactions from the mode mainnet just listed. Okay, so far so good. Going back to my code editor, I'm gonna run from hardhat, npx, actually npm. Yeah, I'm going to run the deploy command, and I'm just going to give it the network virtual mode. And by the way, this is pre-configured, so verification is happening. Something that is not right here. Just give me a sec. Is that the command? Yeah. Oh, something went off. All right. So the thing is, I have the deployments folder, and it contains my previous attempts, and that's what makes it break. So I'll just delete this one. That sometimes happens. And now we have our contract deployed, and it also says the contract is verified, and we can see it in the dashboard. So when I go back here and, whoops, I don't want that, and reload this one, I should be able to see my transaction, which did not happen for some reason. All right, just give me a sec. E1. Yeah, the contract is there for some reason. For some reason, the transaction isn't showing up here in the Explorer.
Yeah, but the contract deployed, right? It's there,
Yeah,
and
yeah,
it
yeah,
says transactions total 1. So is that the one that you sent? Maybe it's.
Yeah, it does. I mean, it sees 18 different requests. This should indicate that it is the transaction that deployed it, but for some reason it's not appearing here. But rest assured, the contract would not appear otherwise in this.
No, for sure, for sure.
In
Yeah,
this
you
view.
clearly
Yeah,
deployed it. Yeah, I think it's maybe
yeah,
a
yeah.
UI thing on the list
So
of
is there?
transactions.
Yeah,
Yeah,
yeah, might be. Yeah. Okay. Let's keep going, and maybe something shows up. So at this stage, you could say, as a smart contract developer, okay, I deploy the latest version of my contracts, and now I can send over the admin RPC to somebody from my team or somebody externally who wants to integrate with this latest version or to try something out. What they could do is actually fork the mainnet. So at this stage, when that one contract is deployed, we saw the contract, we didn't see the transaction, you can actually click fork and say, I don't know, UI fork. And this will take a little bit of time, but again, everything is there. It says that there are 6 virtual blocks in there, and this is the contract that's also deployed. So from now on, if I do anything on this UI fork, it will not be visible on the original network, but I will actually see all the data that came in from there. So in a way, that was, let's say, smart contract staging. I'm gonna head back to this original testnet, which has the contract deployed, and let's keep going and put ourselves into shoes of somebody building a UI. So I'm in the Next.js folder over here, and in there's a similar thing that has happened. So there's the tenderly config with the virtual mode network. Now this is adapted to the VM style config that's used by a bunch of libraries over there, and it's simply referenced in here, the very network in the scaffold config. There's several more modifications that were needed to be done, but this is like the main thing. So now I can just run npm dev and open this one up. And there we go. We have our wallet here. We have the UI here, and I'm gonna go ahead and click connect wallet. Now, what also needed to be done is to allow the burner wallet to be active. So I don't need to add networks to MetaMask and so on and so on. So I'm just gonna click burner wallet, and there is something happening in here that did not happen today.
the concept of a burner wallet there, that's awesome, man. Just for everyone to know, like this is completely live, and you're doing like such powerful
Yeah.
things. So no worries. There's always that something can go a little bit wrong.
Yeah, of
Um,
course. Yeah,
we
I
do have a
am going
question.
to. Oh, go
If
ahead.
you want to answer that, in the
Sure.
meantime, can you multitask here?
Yeah, of course I can.
So Wolfcito here is asking, is it possible to create all the initial configuration through code without using the Tenderly dashboard or UI, similar to what Terraform scripts do?
Yeah. So the network I just created, it is actually done in a similar way. So the script that I ran initially, where's package.json here, the stage new. What this thing did is it just created, using the APIs, created a couple of test nets. So it is in a way like that. This is command based, but we can build it out into something that's configuration based as well. So yeah, this is pretty much going in that direction.
So yeah, so there's no need to actually use the UI. You can do everything with code.
Yeah,
It's
yeah,
programmatically, like set up the new
yeah,
network, connect to it, deploy contracts, etc., etc.
yeah. Pretty much
Awesome.
all that happened here was exactly that. Yeah, this is the the demo effect here. Let me try one more time. Okay, connect. Come on, please work. Yeah, this is not gonna happen. And there's also some sort of problem when I try MetaMask instead. So let me try connecting again. Yeah, this did not go well.
You can prepare for months for a live demo, and there's
Yeah,
always something that
there
can go wrong. Yeah, no worries.
something will happen. Yeah. Let me just
We're
check this
asking
one out.
everyone watching, if we
Oh,
go through these steps and you find a similar issue or whatever, just ping here, ping the Tenderly team, ping us, and we'll
mhm.
get you some help. So don't worry on that.
Actually,
Yeah.
I know what I did. So what I didn't do, I did not uh, connect the next app with the testnet. So I forgot to run this connecting uh, the
Mm.
connecting bit. Yeah. So
Okay, so
the same
you
way
need
I
to run
said
a
connect to
script to
hardhat.
connect it, right?
Yeah,
Mm.
exactly. So now when I go in there, I can see the RPC of the virtual testnet that was created. So um, let me go back in here and reload. And oh, there we go. Now it works. So we are on the Burner wallet. This is a brand new account, so it has 0 ETH because Burner wallet creates these automatically on the go. And if I click grab funds from faucet now, it's already done. It doesn't show here because the refresh interval is a little too long, but I already have 100 ETH. So now if I say hello mode and set that greeting, oh, it is coming from, this is connected to MetaMask. Let's confirm it through that. There's a bit of a mix up now, but doesn't really change much. Let me just reload. Um, let me redo this. Burner, there, grab, hello mode. There we go. It got updated immediately. The counter got updated. So this pretty much worked. So you can imagine somebody building a UI. They will click uh, through these buttons and send crazy transactions and send stuff like that to the network. But when you actually go in there, you will not see. Well, we don't see any transactions here either way because for some reason didn't load. But the cool thing is all these changes that somebody building a UI are doing, well, they remain, let's say, contained. So other people, let's say people building some sort of backend or doing some sort of data analysis on the contracts and transactions, well, they will not see my rubbish transactions as I build a UI in there. So it is a little bit of separation. So everything is nice and clean and tidy, but it also gives a way for people to access the same resources and have everything visible and available in there. And I will finish off with, just a little overview of why could this be useful, what could this be useful for. So on the one hand, it comes with Debugger and the simulator that we'll see, but it also allows integration with third-party contracts. So the stuff that's deployed on the mainnets is already present there. There's real mainnet data through state sync. There's shared API, RPC actually for any sort of type of organization that you do in your team. And it enables continuous integration and automated testing. So you can imagine that that in here, we could actually add a GitHub action that would run all these steps. So it would create a brand new staging environment. It would deploy the contracts. It could also deploy the UI somewhere. We can also go further and say, okay, it could also deploy a custom graph node for indexing all that data. And you have that from the get-go on your working copy of the mainnet without having anything exposed externally. So this is what it sort of ties into altogether. This enables some sort of pre-prod staging and internal testing. So whether or not you have it organized or everybody does it, it's pretty cool for product demoing and beta testing, anything related to community testing. And it can even go further to audit staging. So when the contracts are pretty much ready for auditing, you can actually stage them on a testnet. So auditors can jump in there and try stuff out on actually deployed contracts. So this is just to give you an idea of where all of this could be useful. All right, that's one big part.
I was talking and muted out of stage again.
Yeah.
I really love that with this, like with the tools that you're showing right now, and it may sound like a lot of setup and a lot of things to learn, and I get that. I would push devs to just take the anxiety out, just go to the docs and see that it's not as hard as it may seem, not at all. Everything is like kind of well thought out because this allows for CI and CD, continuous integration and continuous development, which are big words to basically ship fast and break few things, right? Just if you manage to get your configuration on point and actually get a pipeline going, get your tests going and all set up, then you start to gain a velocity as an engineering team that you like we're not used to seeing in Web3. We're used to seeing velocity and fast teams, but we're not seeing reliable things, right? We're so used to just going to a website, to a D app, and something's not working, something's not loading. There are errors all the time, and those user experience problems, you really like reduce them with continuous integration and continuous development because you're testing more things. You have a pipeline where you're checking everything, and you have this positive feedback loop that just goes around, right? This chart that you're showing here, I think it's amazing, and it involves a lot of the things that just end up with a good product, basically a good stable product. So yeah, I love that, and I would love to see Web3 in general follow more good engineering practices and developing software in a fast way because we need to move fast, but in achieving a more reliable and stable product as well.
Yeah, exactly. I'll just thumbs up to all of that because I believe that, you know, if we have to move fast, let's move safely. At least I want a red light blinking if I'm breaking something before it actually comes to the actual customers. Otherwise, well, that's not a good experience for the users.
We have another question from Wolfcito that I know he's building internally. That's why he's super interested. So love it. within Tenderly's capabilities with actions, is it possible to halt the execution of a transaction when it's detected to be initiating? Is it possible?
Okay.
I
Capabilities with actions. I'm assuming that's a reference to Web3 actions. Now, to
think
hold
so.
the execution of a transaction when it's detected to be initiating, um, I I would say that's not possible. But I have to admit, I'm not 100% sure I fully understand the question. So a suggestion would be just to reach out after the workshop. You got my
I'll
Twitter and Telegram.
I'll connect you guys.
Yeah,
I know Wolfcito, he's a big builder in mode, so I'll connect you guys and see
uh,
if you can explore there. So
of
yeah.
course, gladly. All right, now let's jump over uh, to other bits in Tenderly. So I did start with saying that Tenderly was initially, we started out as with building a debugger. So I think it really deserves some attention there, and it deserves showing um, what's actually available for developers. So here I was in the contracts page, I entered swap router 2, and that's Uniswap router, right? And here you can see a lot of information about contract. I will not go into details here. And you can actually see transactions that are happening in there. So this is a full list of latest transactions, and you can filter using different things, the addresses that were involved, the function signature of the function that's invoked, the network date range, and so on and so on. But what I'm really interested in is showing you how a failed transaction looks like and how you might debug it. And by the way, everything I'm showing here from this point on, this is not within the virtual testnet. This is, actual mainnet that I'm looking at right now. Yes, it is. But all the tools that I'm going to show, actually majority of them are available in testnets as well. So same tools that you would use to diagnose problems in production, you would use them for your local development. So I'm going to jump in here. And this says that this function, this was out of gas. Okay, I'm not going to do that one. Let me try this one. Yeah, too little receipt. So here we can see the full trace of that transaction up until the point where it reverted. So it's a very detailed output showing decoded inputs and outputs and all of that. But it's also handy because it can show you storage access. So just flick the switch. And here you can see the loading and the storing of values in different locations. So this is a store, and this is the old value. This is the new value. So this may come in handy if you're really doing low-level analysis. And you can also see event logs. So you can actually see throughout this trace when events were emitted from these contracts. And if this is too much, you can just collapse it and avoid all the function calls within the contract, all the ifs and the fors and the loops, and just have it a little tidier. But what we're going to do here is actually understand why this transaction failed. And it says that it failed because this revert is false. And it says that amount out, whatever that is should be greater than the minimum amount out. And if I unfold this inputs and outputs, I will see exactly the coded values, the coded parameters to this function. And look at this. This is the actual set the right-hand side of this comparison. So this is the value that should be in this, should be adjusted, actually. So now that we know that, we can explore what the value should be. And I'm going to go and click the debug error link right here. And I'm going to zoom in just a little bit. So here you can see the entire code of this contract, and you can see that that's the function that was called. Here's the revert, and it says here, yeah, well, it's too little received. This is the place where that tricky parameter was assigned to. Actually, yeah, it's also a return parameter. So if I, oops, yeah, what we need to do is to figure out what's the value that this thing should have. And I'm just gonna copy this And I'm going to use the evaluate function that's in beta. It's available here. It's not available on testnets yet. So if I click this and just paste this address, what I'm going to get is, after it loads for a little bit, yeah, this is the value that that parameter should have. So this could help you figure out what are the correct parameters of a transaction, or why a function is failing. Is it a bug in the code, or is it an incorrect argument, or something else is wrong? So that could be really helpful. What's also helpful is that I can just add a comment here. So this should be the value, and just comment it out. So I have these findings on me as I keep going. Now, how do I verify that this is the correct value for the parameter? Well, besides simulations, I mentioned that we, besides the debugger, I mentioned that we also have simulations. So there's this resimulate button here, and if I click it, it will open the simulation UI, and that's that's a pretty big UI. So I just zoomed out for a moment, and you have all the stuff that's related to the contract. You have transaction parameters, so you can modify whatever you want. You can even paste any address here, and the simulation will work, because you don't need to have private keys to simulate. You just need addresses. Simulations allow for a bunch of other things like state overrides, but I'm not going to look into that now. I just want us to verify that this argument was right. So I'm going to do that. I have to find that argument here in this box. So it says, here it is, amount of minimum. I'm going to paste the value we just copied, and I'm going to click simulate transaction. And it took us, well, less than 10 seconds to actually get a transaction that will go through. So now we can see also the tokens that have been transferred throughout this transaction. We can see the entire call trace that of the transaction that resulted in a success. What's also cool, if you're interested in an execution of a single function, you can just click here and you can sort of peek into the code, or you can click this debugger icon and it just takes you there. So that's pretty neat. And this is what I referred to when I said that we have very, very detailed call traces to the execution of a transaction. What we also have in there are decoded events. So all the events that were emitted throughout this transaction, you can see them listed in one page in the decoded form, or if you want to, you can see the raw data and raw topics for those events, which is handy sometimes. Then you can see the state changes. So everything is decoded if the contracts are verified, of course, with the old and the new values that are in there. And last but not least, gas profiler. So this is a flame chart that you can click through and go into very specific places in the transaction execution to figure out how much gas was used per those functions. And of course, you can jump into the debugger here instantly from the simulator, and there we go to the place where this function was called. So that's a lot of things that you can find out from the transaction overview page, and it's tightly connected to the debugger, and it's tightly connected to the simulator. So you have all of these tools available either during development or when the thing is live and you're thinking what might have happened there. And we have 10 minutes left. I would just like to come back to the shoes of builders. I guess the question would be, okay, can I use simulations from code? This is very nice that I can use this UI, but can I just do it from code? And of course, since I'm asking the question, the answer is yes. There are two ways you can do that. There is the RPC way. So there's the Tenderly RPC. Practically, it gives you RPC nodes for all of these networks here, and it's growing. So yeah, I'm going to go for mainnet here. And you have Tenderly methods available that simulate transaction, simulate bundle, trace transaction, estimate gas, and so on and so on. So these methods are there if you want to do that thing that we just saw. but you want to do it from your terminal. So this is an example of bundle simulation. You can give it a couple of transactions that you want to simulate, and you also give it a you can also give it a state override. So state override, what it does, it takes a contract, it takes a storage slot within that contract, and it just puts in, now I can scroll in this one, it just assigns this value to that storage slot. And it simulates the execution of these three transactions as if they were consecutively sent one after another, whilst pretending this assignment is true. So I'm just gonna quickly run this one. It's not going to be fun, but let's do it. Oh, rate limit exceeded. Okay, I just need to put in this thing. Yeah, demo effect. Homework for everybody. You can give it a go after the session. So to wrap it up, everything that you saw and that you see on the interface, it's completely doable from the command line, or you can just use any chain interaction libraries to do that. Or if you really want to go for REST API, there's also a version in there. What's most important to know, both of these simulations, they will give you information such as decoded logs, it will give you decoded traces, it will give you the exact gas used, and all sorts of information about the transaction execution.
That's sick. Super important to have a programmatic way for devs to use. For some reason, I get it though. We hate UIs, so um, it's great that you can control everything on the with code. And the debugger is, I know it's one of you guys like main feature because it's being around for so long, and it's one of the most advanced of there, if not the only one. I don't really know if there are other tools that analyze so deeply and decode even events and stuff. So it's super powerful. I know it can get overwhelming to see all that information in like one page. It does. I get it. I've been
Yeah.
there. I got a workshop. I've been in a workshop that you guys gave like a year ago or so. I was impressed with the amount of information, and it's just going there, start clicking things, testing like debugger, getting used to it, and you'll be impressed with the amount of information you can get with it. So it's actually a great tool to be adding. While you were explaining all of this, there was
Yeah.
something happening in the chat. So we really need to share this. So we had Wolfcito's question talking about actions, Web3 actions in Tenderly, right? Asking if he could hold the execution of a transaction. Luckily, you have an angel around watching here from
Yeah.
Tenderly that answered to Wolfcito saying that if by initiated you mean a transaction in the mempool, yes, you can cancel it. So I think Wolfcito was asking about I initiated a transaction that's living in the mempool. It was not yet executed. And I want to know if I can stop that execution and prevent it from getting added to a block. So yes, apparently you can do it. And Wolfcito super happy. And that is exactly the answer he was looking for. So
All right. All
happy
right.
to see what Wolfcito builds later on with that.
Awesome. Yeah, I wasn't sure that was the question, but yeah, definitely doable.
Yeah, great. And Wolfcito has another question on after performing the simulation. So we're talking about simulation now. Is it possible to directly use the bundle simulation performed internally on the main network?
Yeah, so essentially what you're giving to this simulate bundle are transactions that you would execute on mainnet. So if you simulate it and then you see the results and you're happy with the results, for example, you see that all the asset changes look right, or that, well, transaction didn't fail to start with, then you can just take it over and send it to the actual mainnet RPC, because it's pretty much the same node. It is a different let's say RPC. So that is completely doable.
Awesome. Awesome. I think, well, Sito, you got a lot to research later on and to test. So happy to see what you build, man. And this is exactly what we do it. We bring in infra partners, amazing dev tooling that we added to Mode and that we're working with, so that you
Mhm.
builders can actually leverage that and build better DApps. That's basically it. Um,
And
Anything else you would like to add for now? I don't see more questions in the chat. We've gone through very powerful things that this was just barely an overview, right? Maybe we can talk about
yeah,
like what's missing, what else is coming.
yeah, exactly. So before we jump into that, I would just like to invite everybody, if you have any sort of questions or some ideas or something was unclear, uh, on the docs you have the schedule office hours thingy. That's when uh, one slot a week when well, you can just talk to us, whatever sort of ideas or projects or solutions you're building, and we can find ways where how Tenderly can support all that and what's the best way to use the platform. Um,
Are
yeah.
you gonna be there
So
in the
to
office hours? You're the
yeah,
one
yeah, I'm doing
helping. Nice.
I'm doing the office hours exactly.
Awesome, awesome. I'll send some people over your way then.
Awesome, awesome. Yeah. Uh, so there's that. Go ahead and just book a call, and we'll do it. It is a group call, so it will be sort of a relaxed conversation, a couple of people solving problems, but definitely can be a very very fun and sometimes intense experience. So on your question about something new that's coming and what's happening. So as I said, the latest thing that we added are virtual testnets, and as you said it in the very beginning, we're sort of doing things so they fit together in a in a modular, composable way, and this is the direction that we're going in, to have the platform very nicely integrated. You saw the testnets, and all the tools that are used externally will sort of become more and more tightly integrated to it, and with a smoother user experience. So that's something that we're heavily focusing on, and there's a lot of energy involved in directed into solving the problem of staging, and because as we said, staging is important, because your developer life will be better with it, and the products will be healthier and let's say less breaking. So that's something that is also happening, and should come in the near future.
Totally agree, man. Totally agree. I hope we start seeing a lot more CI/CD around, a lot more DevOps in Web3 as well. I wanna our DevOps folks coming from Web2 just come here, put standards
Mhm.
in, help build healthy pipelines that start working faster, but in a more reliable way. And yeah, just that. So if you waste it, if you need to contact the Turnelly team, if you have any issues, if you have any questions, the office hours is great because you'll bother our friend here directly in a call with other folks, just learning and networking as well. So something, this has nothing to do with the workshop, but something that I've
Mhm.
talked a lot with devs is that they always tell me, the better the devs, they tell me I'm really bad at networking. So take the advantage that in this industry we're super close. Everyone's super close, everyone's super reachable. All the teams that are building stuff are like really, really easy to reach. So go book some office hours, show Nana and show the Tenderly team the things that you're building, even if you think it's a small dump app. Come show it in your office hours, connect with other devs, tweet about it, share the stuff. You can see Wobsito came here, asked their questions, and Tenderly directly answered the question. So it's awesome to see a super engaging team working closely with devs. Take advantage on that, leverage that, connect with the teams, show what you're building, and you'll do great. So yeah, thank you very much for being here. This was super, super insightful. Lots of products and lots of things to go around and see with Tenderly. And what is coming for, like, we're gonna do more workshops with you, right? Like I'm excited. I want to see more. I want to see more in-depth stuff, more things from you. So what do you got for us in the future? Any insights for the future for that?
Yeah, so I have some of my ideas for the future, but what I'm actually curious is what is community curious about.
Awesome.
So it can be, yeah, it can be a lot of things. So I would definitely be happy to hear what's on, what's on people's mind and what would they like to dive deeper in. But what I could definitely say that we might do is something around securing the apps. You remember I mentioned simulations and alerts that are aiding to it. There's also some stuff around staging that we can go more deeply into. So there's a lot of different topics that that we can talk about.
Awesome.
Stay
So
tuned.
we'll talk to the community, see what's missing, what else needs more explanation, or what they want to learn more of, and see how they can become power users of Tenderly and the services that you guys have. So yeah, thank you very much. I'm super
So
happy to have you
thank you.
here. This was super fun, super insightful. I hope this is going to help a lot of builders. We actually have a bootcamp going on right now with Bcamp, and I know a few teams are going to be probably checking a few of the services. I'm a mentor there, and I already share with my team. So there, for sure, we're going to use one of the
Awesome.
services around. Yeah, for sure.
Awesome.
Um, so yeah, thank you very much for being here. I hope this was useful for all you builders listening. We got a lot of people online and really happy to see that. Remember, this is gonna stay on YouTube, so you're gonna be able to come back and check this out forever and ever. And yeah, you know where to reach us. You know where to ask your questions. Now it's your time, builders, to just go and build. Yep.
Yeah. Go and build and good luck.
Good luck, guys. See ya.
See ya. Bye bye.